Hey guys, good evening and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So people, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible and visible to every one of you. Quickly let me know in the chats with the thumbs ups. Yes? Am I perfectly audible and visible to everyone? Quickly, everyone in the chats, everyone. Good evening, guys. Good evening. Welcome back. Welcome back. Welcome back. Welcome back. Wonderful, guys. So, the question which I gave you as the homework in the last session, I could see the comment section flooded with the answers, flooded with the right answers. That's one amazing thing which I saw in the morning, right? So, I would want you guys to keep the Josh always high till your NEET 2023 examination, right? Do not create any backlog at all at this particular point of time. Do not do that at all. Okay? So whatever sessions we take on this channel, try to attend all the sessions live at any cost. Okay? Perfect. Yeah, one more thing. A lot of people are asking about the notes. From today onwards, I'll be putting the notes on the Telegram channel. Okay? Right after the session, you'll be getting the notes of every particular session which I'll be taking here. Is that cool? Should we start? Give me some thumbs ups in the chats. Should we start, people? Give me some thumbs ups in the chats. Let me see the Josh of the today's session as well. And guys, one thing I would want to tell you, you will have to be with me for at least 2 hours today. Okay? At least for 2 hours, you have to be with me today. Are you ready for that? Are you ready for that? The chat box should not stop at all. It is not supposed to stop. It should continuously run. Yes? Wonderful, guys. Perfect, perfect. And at the same time, the ones who have just joined the channel, I would want you guys to, first of all, like the session. Share this particular video with everyone, whosoever is preparing for NEET 2023. This particular session is for every single guy. And if you have not subscribed to the channel yet, please and please do subscribe to the channel, so that everyone remains notified about all the sessions which we take live on this particular channel. Okay? Are you guys ready to do that? Are you guys ready to do that? Well, I can see there are almost some 400 people watching and the likes are still around 170. That's not done. That's not done. Yeah? Perfect, guys. Perfect. So let's get going then. Let's get started. So today, as per the schedule, I have kept 2 chapters basically. One is states of matter, one is solid state. So we'll be starting from the chapter states of matter. In the chapter states of matter, let me quickly tell you, there are some 5 short concepts. 5 short concepts are there basically, from which questions are 100% going to be asked in your NEET examination. So I'll try to cover all these 5 concepts in detail, in depth, from the basics, with all the problem patterns, everything with you in the today's session. And after that, we'll move on to the chapter solid state. Perfect? So please and please take a note of every single thing. Whatever I'll be mentioning on the screen, every single thing is going to be really very important. So let's start now without wasting a lot of your time. So dear students, the first topic which we are going to deal with from the chapter states of matter, that's going to be gas laws. Gas laws. Okay? So let's start with the first topic. That's going to be your Boyle's law. Boyle's law. So first of all, what this Boyle's law exactly is all about. Let me tell you first thing, whenever a question comes from the gas laws, majority of the times, the question is going to come from the graphs. Okay? So gas laws, which I'm going to teach you right now, whenever question comes from the gas laws, majority of the times, the question is going to come from the graphs related to these gas laws. Okay? So let's see exactly what the law states and what these graphs are all about, which I'm talking about. See guys, as far as the Boyle's law is concerned, Boyle's law states that for a fixed amount of gas, for a fixed amount of gas at constant temperature, pressure of the gas is inversely proportional to the volume of the gas. Let's write exactly its mathematical form. As per the Boyle's law is concerned, pressure of the gas is inversely proportional to the volume of the gas, and this particular statement, it's valid only when number of moles and temperature of the gas is kept constant. So what it means exactly? It's a very simple statement, guys. It's very simple. For example, over here you are taking one container. This is the container which you are taking, and there is a piston fitted at the top. This is the piston fitted at the top. The piston can go up, it can come down as well. Okay? Let's say I'm keeping the ideal gas inside this particular container. These are the ideal gas molecules inside the container. Okay? My dear students, is there any hole in the container? There is no hole. There is no leakage in the container. That means the gas which I have kept inside the container, this gas is not going to come out, and at the same time, some extra gas cannot go inside the container. Very simple. I have taken a container which is closed on all the sides. The container is closed on all the sides. I have kept ideal gas inside the container. Since there is no leakage at all, right? So this particular gas is not going to come out of the container, nor some extra gas is going to go inside the container. What does that mean? That means I'm keeping number of moles of the gas as constant. I'm not going to let the moles of the gas to change, right? I'm not going to let the moles of the gas, I'm not going to let the amount of the gas to change, number one. At the same time, I'm not supposed to let the temperature of the gas to change as well. Why is that? Because the law which I'm going to talk about, this law is only valid when number of moles and temperature of the gas is kept fixed, is kept constant. Then only I can apply Boyle's law to some ideal gas. Okay? Since I've taken the ideal gas, I've kept its moles, I've kept its temperature constant, now I can clearly use Boyle's law for this particular gas which is inside the container. Now what the Boyle's law says? Boyle's law says pressure of the gas is inversely proportional to volume. What it means? It means if you increase the pressure of the gas, simultaneously volume of the gas will decrease. Right? If you increase the volume of the gas, pressure of the gas will decrease. It's simple, guys. For example, imagine like this. Let's assume this piston is going up. If the piston goes up, what happens to the volume of the container? Volume of the container is increasing. I'm assuming that piston is going up. That means volume of the container is increasing. If volume of the container is increasing, that means the volume of the gas is also increasing, right? So I'm lifting the piston up. That means volume of the gas is increasing. At the same time, if the volume of the gas is increasing, can I say molecules are going far from each other? Absolutely. And if the molecules are going far from each other, can I say the number of collisions inside the container will decrease? And if the number of collisions are decreasing, that automatically means pressure is decreasing. As simple as that. So when I'm trying to increase the pressure, increase the volume of the gas, what is happening to the pressure? Pressure is decreasing, right? As simple as that. Just increase the volume of the gas, pressure will decrease automatically, provided number of moles and temperature of the gas is kept fixed. Okay? Now guys understand. Let's just do one thing. Let's remove this proportionality sign here, and instead of this proportionality sign, let me put a constant K. Right? Let me put a constant K over here. This K, which is the constant, this K is something which I call as the Boyle's constant. I call it as the Boyle's constant. Now you must be thinking, what is going to be the exact value of this K? Right? How to get the exact value of this Boyle's constant? My dear students, I'm damn sure you would have come across something called as ideal gas equation. As far as the ideal gas equation is concerned, We can say P is equal to nRT divided by V. This is your ideal gas equation. P is equal to nRT divided by V. What is the equation which we got as per the Boyle's law? As far as the Boyle's law is concerned, this is the equation which we got. P is equal to K by V. Now I'm writing the equation which we got from the Boyle's law. P is equal to K by V. So how many equations we have? Two equations. My dear students, if you just compare these two equations, this is pressure here, this is again pressure. This is volume here, this is again volume. That means this K automatically is equal to what? This K is equal to nRT. So do remember the value of Boyle's constant K, it's always equal to nRT. Okay, this is something which I would want you guys to remember. Perfect. At the same time, look at this particular equation. Can I write this particular equation in a different format as well? PV is equal to K. You can write it like this as well. PV is equal to K. Now you must be thinking, is there any significance for this particular equation? Is there any significance for this particular equation? Before talking about the significance, let me tell you this particular equation. It is called as the equation of state for isothermal processes. It's called as equation of state for isothermal processes. Okay. Now what is the significance of this particular equation? Understand properly what I'm going to say. The significance of this particular equation. The product of pressure and volume is equal to constant. What it means? What it means? Have a look what it means. Just imagine the gas which is inside the container. Let's imagine its pressure is 10 atm. When the pressure of the gas is 10 atm, let's assume the volume occupied by the gas was 5 liters. Let's assume that. When the pressure of the gas was 10 atm, let's assume the volume occupied by the gas was 5 liters. Right? Now, dear students, if I ask you, since now the pressure is 10, volume is 5, if I multiply this P with V, what do I get? 10 multiplied by 5 comes out to be 50. Correct? Simple. Now, dear students, if I decrease the pressure from 10 atm to 5 atm, let's say I'm decreasing the pressure of the gas from 10 atm to 5 atm. I'm decreasing the pressure. But we know if we decrease the pressure, volume has to increase. Right? I'm decreasing the pressure. Volume will increase. Initially the volume was 5 liters. Now the volume has to increase. Now the volume accordingly will adjust in such a way that the product of pressure and volume again comes out to be 50 only. Did you get it? Did you get it? Can I say initially when the pressure was 10 atm, volume was 5 liters, P multiplied by V value was 50. Now I decrease the pressure. Volume eventually increased in such a way that the product of pressure and volume again is coming out to be 50 only. Yes? So can I simply say something like this? On changing the pressure of the gas or on changing the volume of the gas, is the product of pressure and volume changing? Product of pressure and volume does not change at all. Right? Product of pressure and volume does not change at all in case of the Boyle's law. I'm sure this is clear to everyone. Once let me know quickly in the chats if you got this particular concept. Everyone guys, everyone, quickly in the chats. Everyone, give me some thumbs ups in the chats if you got the concept which I wanted to convey. Quickly. Quickly guys, everyone. Yes or no in the chats? The product of pressure and volume is always constant. If you change the pressure, if you change the volume, the product of pressure and volume is not going to change at all. Quickly, let me know in the chats with the thumbs ups if it is clear to everyone. I want everyone to say it. I want everyone to let me know in the chats whether it's clear. Then only I'm going to continue. Everyone means everyone. Yes? Wonderful guys, perfectly done. Now, if I call this term as P1, I can call this term as V1 as well. If I call this term as P2, then this value has to be equal to V2, right? So, can I say from this particular equation, P1 V1 has to be equal to P2 V2. This is one very simple equation which you will be using in majority of the questions as far as the Boyle's law is concerned. This is the equation which you will be using in majority of the questions as far as the Boyle's law is concerned. Okay? Now, dear students, there is something really amazing. That is the graphs related to Boyle's law. Those are important. And I would want you guys to take a note of every single graph which I'm going to give you, because every graph is really, really very important. Okay? So I'm writing the heading as graphs related to Boyle's law. Majority of the times, whenever question comes from the Boyle's law, it's most of the times going to be from the graphs. Okay? Now people have a look what kind of graphs can we plot as far as the Boyle's law is concerned. So dear students, we know as far as the Boyle's law is concerned, the basic equation is P is equal to K divided by V. This is the basic equation, P is equal to K by V. The first graph which I'm going to plot over here, that's going to be between pressure and volume. Pressure and volume. Now you tell me one thing. Can I say I'm plotting pressure along y-axis? Absolutely. I'm plotting volume along x-axis? Absolutely. I'm doing that. I'm plotting pressure along y-axis, volume along x-axis. I want to plot a graph between pressure and volume. Now you tell me what is the basic equation. The basic equation as per Boyle's law, that's P is equal to K divided by V. Right? This is the basic equation. Now this P you are plotting along y-axis, so instead of P I'm writing Y is equal to K divided by. Instead of V, since V I'm plotting along x-axis, so instead of V I'm writing X. Now you tell me whether this Y and X, are they directly proportional to each other or inversely proportional? What do you see? This Y and X, these are inversely proportional to each other. Do remember one thing, from now onwards, whenever you need to plot a graph between two variables which are inversely proportional to each other, whenever you need to plot a graph between two variables which are inversely proportional to each other, the nature of the curve always is going to be a rectangular hyperbola, like this. This graph is called as rectangular hyperbola. It neither touches the y-axis nor it touches the x-axis. And this graph is made when the temperature of the gas is kept constant, and this particular graph is something which you call as isotherm. This is something which you call as isotherm, right? Now, dear students, can we make few more graphs related to Boyle's law? Absolutely, you can do that. Absolutely, you can do that. Have a look. Understand properly. For example, you have to plot a graph between pressure of the gas versus 1 by volume. P versus 1 by V. You tell me one thing. This P, you're plotting along y-axis. Right now, along x-axis, what are we plotting? Along x-axis, we are not plotting volume. Along x-axis, we are plotting 1 by V. We are not plotting V. We are plotting 1 by V along x-axis. Again, I would want you guys to write the basic equation. And basic equation is P is equal to K by V. Or you can write P is equal to K multiplied by 1 by V. No issue at all, right? This P over here, this is something which you are plotting along y-axis, right? 1 by V you are plotting along x-axis. 1 by V. That means this whole term you are plotting along x-axis. This K I'll be calling as M. Y is equal to mx format. Y is equal to mx format. Do tell me in the chats quickly, what should be the nature of the curve for the equation y is equal to mx? Y is equal to mx. It is going to be straight line passing through the origin, right? Y is equal to mx. It's always straight line passing through origin. So this is going to be the graph, right? And this graph again is made when the temperature of the gas is kept constant. I'm sure it's clear, right? This is one more graph which I would want you guys to remember. Similarly, if I want to plot one more graph, let me see if you can make this or not. For example, I need to plot a graph between P by V versus 1 by V ka square. Let's say this is the graph which I have to plot. Let's assume this is the graph which I have to plot. Now, dear students, be careful. Do tell me in the chats. Along y-axis, what am I plotting right now? I'm plotting P by V. Along x-axis, what I'm plotting right now? I'm plotting 1 by V ka square along x-axis, right? P by V, I'm plotting along y-axis. 1 by V ka square, I'm plotting along x-axis. Now, you tell me what is the basic equation. Basic equation is P is equal to K divided by V. Absolutely. Or can I write it like this? P is equal to K multiplied by 1 by V. Absolutely. Now you have to use your brain a bit here. Tell me one thing. Are we plotting pressure along y-axis? No. We are plotting P by V along y-axis. We are not just plotting pressure. We are plotting P by V along y-axis. That means I do not need P here. What do I need? I need P by V. And how do I get P by V? How do I get P by V? I'll be dividing this equation throughout by V. Dividing V from left side, dividing V from right side, so it becomes 1 by V square. Right? Now, dear students, you tell me. P by V, this whole term, you're plotting along y-axis, as you can see. 1 by V square. 1 by V square, you are plotting along x-axis, and this K is going to be your M. Y is equal to mx. Is it again going to be a straight line passing through origin? Absolutely, it's going to be a straight line passing through origin. Perfect? Right? Now, dear students, there is one more thing which I would want to convey here, which I want you guys to remember. There is a special type of question which is asked from the Boyle's law as far as the graph is concerned. Right? And I'm damn sure you would have you would have seen that question already. The question is like this. This is pressure. This is volume all along x-axis. Now, you know, pressure versus volume curve. It's hyperbola, right? Let's say one hyperbola which is made at temperature T1, one more hyperbola which is made at temperature T2, one more hyperbola which is made at temperature T3. Now you need to tell me whether T3 is greater than T2 is greater than T1, or T3 is less than T2 is less than T1, or T3 is equal to T2 is equal to T1. These are few options which I'm giving you. What do you think? Quickly, let me know quickly in the chats. Everyone means everyone. Everyone means everyone. Quickly. There is a simple method which I'm going to give you from now onwards. Whenever you see these sort of questions, how to manage these sort of questions, there is a simple trick for that. Have a look. Have a look, people. I can see a lot of people are coming with option A. I don't know the answer. Let's give it a try. See how to tackle these sort of questions. So, dear students, what exactly you'll be doing here? Always, whenever you will have to compare these temperatures, basically, you'll be drawing a straight line parallel to y-axis. Drawn. After drawing the straight line, just mark the points where the line cuts these curves. These are the 3 points where the line cuts these curves. Draw a straight line parallel to y-axis. Mark these points. Now, along these points, get the corresponding y-axis value. See, at this point, let's assume the pressure is P1. At this point, let's assume the pressure is P2. At this point, let's assume the pressure is P3. Okay? After drawing the straight line, mark the points. Take the corresponding y-axis values. Y-axis is pressure axis. So take the corresponding pressure values. P1, P2, P3. Now you tell me, this is P1 from here to here. This is now P2. This is now P3. So can I say after looking at the pressure axis, I got to know P3 is greater than P2 is greater than P1. This is something which I got to know. P3 is greater than P2, which is greater than P1. Now, dear students, use the ideal gas equation. Ideal gas equation says P is equal to nRT divided by V. P is equal to nRT divided by V. Since you have drawn a straight line, parallel to y-axis, that means you are keeping the x parameter constant. And what is the x parameter here? It is volume. So, you're drawing the straight line, that means you're keeping the volume constant. Number of moles are already constant. R value is already constant. So, can I say pressure is directly proportional to temperature? Absolutely. So, more the pressure, more the temperature. More the pressure, more the temperature. More the pressure, more the temperature. That means T3 has to be greater than T2. It has to be greater than T1. Let me know quickly in the chats. Whenever this sort of a question comes in your exam, will you be able to solve it? Yes or no in the chats quickly. With the thumbs ups, everyone, people. With the thumbs ups. Everyone means everyone. Quickly. Then only I can move on to one more gas law. Quickly, everyone, let me know with the thumbs ups if this is super duper clear to everyone. Yes? Wonderful, guys. Great job done. Perfect. And the ones who have not subscribed to the channel yet, to subscribe to the channel first, okay? So that you remain notified about all the sessions. By the way, tomorrow morning we are taking an amazing session. Do you know that? Tomorrow morning 9 a.m. we are taking the most predicted NEET 2023 paper, right? In which we'll be discussing 90 questions from biology, 45 from chemistry, and similarly 45 from physics. Morning 9 a.m. Remember that, tomorrow. Perfect? Alright people, so let me move on to one more gas law. This was your Boyle's law. Now all the other gas laws are very simple. The way we dealt with the Boyle's law, in the similar way, we are going to deal with the other gas laws as well. Have a look now. The second gas law which I'm going to talk about, that's your Charles law. That's your Charles law. Now I'm not going to write the statement. We'll just see the application part properly. Charles law states that volume of the gas is directly proportional to temperature of the gas, but the temperature has to be in Kelvin. And this particular statement, it's valid only when number of moles and pressure of the gas is kept constant. Charles' law states that volume of the gas is directly proportional to temperature of the gas in Kelvin, provided number of moles and pressure of the gas is kept fixed. So that means Charles' law, it is not valid under all conditions. Charles' law is only valid to a gas, to an ideal gas, which is kept at constant pressure. Do remember this, number one. Number two, if I remove the proportionality sign, I'll be getting a constant. It's going to be K and temperature T over here. Nowadays students, again you got a constant. Again you got a constant K. If I ask you, what should be the value of this constant, which you call as the Charles constant? If you ask me what should be the value of K, what is the value of K? You should be able to solve it on your own now. Do remember, write the ideal gas equation first. Ideal gas equation says P, or let me write the ideal gas equation in this format. V is equal to nRT divided by P. It's the ideal gas equation basically. PV is equal to nRT. What is the basic equation as per Charles' law? V is equal to K multiplied by T. Absolutely. If you compare these two equations, this is V here, this again V. Temperature. That means this K automatically becomes equal to nR by P. So K value, you got to know, it is equal to nR divided by P. This is one more thing which I would want you guys to take a note of. Okay. Nowadays students, one more amazing thing. Do remember it. You got to know V is equal to KT, right? If I want to write the same equation in a different format, I'll write V divided by T is equal to constant K. V divided by T is equal to constant K. Can anyone tell me the significance of this equation? Similar equation which we got in Boyle's law. PV is equal to K. On changing the pressure, on changing the volume, the product of pressure and volume does not change. In the similar way, V by T is coming out to be constant. That means on changing the volume or on changing the temperature, the division of volume and temperature is not going to change. The division of volume and temperature is going to remain constant. Yes? You got it? In the Boyle's law, the product of pressure and volume is constant. In the Charles' law, the division of volume and temperature becomes constant. That means I can straight away write an equation. V1 divided by T1 is equal to V2 divided by T2. Perfect? Right? Right, people? Now comes a point. That is, what are the different types of graphs which we can draw related to this law? Let me show you some important graphs related to the Charles law. Have a look on the different graphs. The first graph which I'm going to draw over here, that's going to be between volume and temperature in Kelvin. Again, the same procedure I want you guys to follow. You're plotting volume along y-axis, you're plotting temperature along x-axis. Now what is the basic equation? That is V is equal to KT. So write the basic equation. V is equal to K multiplied by T. Nowadays students, one simple thing. You are plotting this volume along y-axis. You are plotting this temperature in Kelvin along x-axis, and this K automatically becomes your M. Y is equal to mx. Isn't it going to be a straight line? Absolutely, it's going to be a straight line like this. If I ask you what will be the slope of the straight line, slope is represented by M. and m over here is k. Slope is represented by m and m over here is k. So I would say the slope of this curve over here is equal to k. But we know the value of k exactly, right? We know the value of k. K is equal to nr by p. K is equal to nr divided by p. And this particular graph, it is made when the pressure of the gas is kept constant. So I'll be calling this particular graph as the isobar. Is this clear? This has to be clear to everyone. Number one. Let me plot one more curve. Let me see if you can solve that or not. Let me make one more graph over here. I'm plotting the graph between, for example, volume and temperature in degree centigrade. Volume versus temperature in degree centigrade. Can you let me know what should be the nature of this graph? Volume versus temperature in degree centigrade. My dear students, again the same procedure. You're plotting volume along y-axis. You're plotting temperature in degree centigrade now along x-axis. Right? Now along x-axis. Now, dear students, write the basic equation. That's V is equal to K multiplied by T. But I told you in the beginning, this T over here is in Kelvin, right? So this temperature right here is in Kelvin. But if I ask you, whether do we need this temperature right now in Kelvin or degree centigrade? Have a look. You're plotting volume along y-axis. So V over here we have. But right here in this equation, we have got temperature in Kelvin. But what do I need? What do I need? I need temperature in degree centigrade. So let me convert this temperature in Kelvin into temperature in degree centigrade. So you're going to write V is equal to K multiplied by. Instead of temperature in Kelvin, you'll write temperature in degree centigrade plus 273.15. Right? Temperature in Kelvin is always equal temperature in degree centigrade plus 273. Now just shuffle the equation. That's it. So I'll say V is equal to K multiplied by temperature in degree centigrade plus this is going to be 273 K over here when you multiply it. Throughout. Now you are going to let me know. This volume you are plotting along y-axis, temperature in degree centigrade along x-axis. So this is your m and this whole term is your c. So y is equal to mx plus c. Y is equal to mx plus c. Y is equal to mx plus c. What will be the nature of the curve? Y is equal to mx plus c. Straight line starting from here above the origin. This is the graph for y is equal to mx plus c. What do we call this m as? This m is called as slope. Slope is equal to k and k is equal to nr by p. So I would say slope of this graph is equal to nr divided by p. And at the same time, dear students, one more thing. This c over here, this is something which we call as intercept. Intercept. This c is what we call as intercept. Its value is 273k. Intercept is the distance. Intercept is the distance from the origin to the point from where the graph starts. So from the origin to the point where the graph starts. So this distance is something which you call as intercept. And intercept value is equal to 273k. K is basically nr by p. Right? Perfectly done. Now one more thing if I ask you. For example, tell me the answer of this question. Tell me the answer of this question. Let's say I'm giving you a question like this. Let's say I'm giving a question like this. This is volume and this is temperature in Kelvin. Volume versus temperature in Kelvin. Now I am giving you three graphs like this. This is the first graph which is made at pressure P1. Second graph made at pressure P2. Third graph made at pressure P3. Tell me the relation between P1, P2 and P3. Let me see what should be your answer. Let me see what you will say. Quickly. I want you guys to be involved in the chats. Everyone. This session has to be very, very, very interactive. The session has to be very interactive. Quickly. I can see everyone has not liked the session yet. Do like the session. Do subscribe to the channel. This is the only English channel which is going to last lifelong. Okay? Yeah? What should be the answer of this question? Quickly, everyone. Okay, let me show you. Let me show exactly how it's to be done. The same procedure which I gave you a few minutes back. I gave you one simple procedure if you remember. I told you to draw a straight line. This is the straight line, right? Now mark these points. Mark the points. Now get the corresponding y-axis value. Get the corresponding y-axis value. Along y-axis you have plotted volume basically. So this has to be V1, this has to be V2, this has to be V3. Now you look at the y-axis, you look at the volume axis and tell me which volume is more. I would say V3 is greater than V2 is greater than V1. V3 is more than V2, V2 is more than V1. But I do not need the relationship between the volume. I need the relationship between the pressures, right? Use the ideal gas equation. P is equal to nRT divided by V. Perfect. Since you have drawn a straight line parallel to y-axis, that means you have kept the x parameter constant. What is the x parameter here? X parameter here is temperature. So you have kept temperature constant. Temperature constant, right? Perfect. R is already constant. Number of moles already constant. So can I say pressure is inversely proportional to volume? So more the volume, lesser the pressure. More the volume, lesser the pressure. More the volume, lesser the pressure. It tells you categorically that P3 has to be less than P2, which has to be less than P1. So remember, this sort of a question is frequently asked in your examination. Is it clear? Is it clear to everyone? People, quickly, let me know in the chats quickly. Everyone. Everyone in the chats. Is it super clear to everyone? Yes or no? Give me some thumbs ups in the chats. Give me some thumbs ups in the chats if it is clear to everyone. One more graph I would want to plot here in case of Charles' law. That might confuse you afterwards. You can plot many graphs, by the way. I'm going to plot a curve between log of V versus log of T. This is the graph which I need to plot now. This is the graph which I need to plot now. Now you guys are going to give it a try. You're plotting log V along y-axis. You're plotting log T along x-axis. Correct? Use the basic equation. Basic equation says V is equal to K multiplied by T. Correct? But I do not need V here. What do I need? I need log V. I do not need T here. What do I need? I need log T. So I'll be multiplying this equation throughout by log. I'll be multiplying this equation throughout by log. So I'll say log of V has to be equal to log of K multiplied by T. Correct? Now, dear students, it's going to be log V is equal to log of M into N. Use maths. Log of M into N is basically log of M plus log of N. Correct? Correct? Now, dear students, one more thing. Log V you are plotting along y-axis, right? Log T you are plotting along x-axis. So this whole term has to be this C. The sign in between is plus. So before log T there is nothing. That means there is 1. So this 1 is basically the value of M. Y is equal to mx plus C. Y is equal to mx plus C. Straight line, but it won't be passing through origin. It will be like this. What about the slope of this curve? What about slope of this particular curve? Slope is represented by M. M value is 1. M value is 1, right? What is slope actually? Slope is nothing. Slope is basically tan of theta. You would have studied in physics. Tan of theta. So tan theta value is 1. When can be tan theta 1? When can be tan theta 1? Tan theta can be only 1 if theta will be taken as 45 degree. That means the angle which the graph makes with the positive x-axis in the anti-clockwise direction, this angle has to be 45 degree. I hope this graph is also clear to everyone. Let me know once in the chats. If everything is clear, then only I'll be moving on to one more graph. Then only I'll be moving on to one more topic, which is what we call as Gay-Lussac's law. Let me know quickly in the chats. Let me know quickly in the chats. And I want everyone to be with me till the end because we have to finish it off today. Let me know quickly in the chats, guys, with the thumbs ups if every single thing is clear. If every single thing is clear, let me know quickly in the chats. Yes. And I would want the honest replies from everyone. Don't bluff at all. If it is clear, then tell me yes. Then give me thumbs ups. (2024) schedule I'll be giving you afterwards. Just wait for it. Don't worry. Wonderful. Good job, guys. Let's move on. Gay-Lussac's law. I'm not going to write its statement. Let's see what this Gay-Lussac's law is all about. Gay-Lussac's law states that the pressure of the gas is directly proportional to temperature of the gas in Kelvin, provided the number of moles and volume of the gas is kept constant. This is the simplest statement of the Gay-Lussac's law. Pressure of the gas is directly proportional to the temperature of the gas in Kelvin, provided the moles and volume of the gas is kept fixed. So if I ask you a question, whether Gay-Lussac's law is applicable to the ideal gas under all conditions, the answer is no. Gay-Lussac's law is applicable to an ideal gas when number of moles and volume of the gas is kept fixed. Yes, number one. Number two, remove the proportionality sign. It's going to be constant K multiplied by T. So basically, this is your basic equation related to your Gay-Lussac's law. Correct? Now, if you ask me what is the value of K, now you know your ideal gas equation. That's P is equal to nRT divided by V. Right? P is equal to nRT divided by V. This is your ideal gas equation. What is the basic equation as per Gay-Lussac's law is concerned? P is equal to K multiplied by T. If you compare them, P, P, T, T. That means this K over here, it's equal to nR by V. So you got the value of K, my dear students. You got the value of K. K is nothing. It is just nR divided by V. It is just nR divided by V. Clear to everyone? In the similar way, if you want to write the equation in this format, P divided by T is equal to constant. It's completely fine. You can write this equation like this as well. No issues. Now, if I ask you, do you know the significance of this equation? Yes. It simply tells you that if you want to change the pressure, if you want to change the temperature, on changing the pressure or on changing the temperature, the division of pressure and temperature, is not going to change. That's going to remain constant. So from this particular equation, you can get this right. You can write this equation as well. P1 by T1 is equal to P2 divided by T2. This is the equation which I'll be using in the numericals, in the questions. Right? Perfect. Now, if I ask you to plot the graphs, you should be able to plot the graph as well. You should be able to plot the graphs as well, people. For example, let's say one graph I'll show you, rest you can continue on your own. Pressure versus temperature. Just plot this graph. Pressure versus temperature in Kelvin. Can you do that? You should be able to. Since you're plotting pressure along y-axis, temperature you're plotting along x-axis, the basic equation says P is equal to K multiplied by T. P is equal to K multiplied by T. Right? Pressure you're plotting along y-axis, temperature you're plotting along x-axis. This has to be M. Y is equal to mx. Straight line passing through origin, right? But this particular straight line is only made when volume of the gas was kept constant. So you'll be calling this graph as the isochore. This graph is called as the isochore. Similarly, you can plot all the graphs in the similar way, the way I did, right? The way I plotted different graphs, you can plot anything, correct? For example, if I ask you what will be the slope of this curve? Slope of this curve, slope means M. Slope means M, right? Slope means M. So you will say slope of this graph is basically M. M is equal to K and K is nR by V. K is nR by V. That's all. Different graphs. Different graphs you can plot, yeah? Perfect. One more graph, for example. Let's say you have to plot a graph between P versus, let me see if you can make this or not. I want to see how active you are in the chats. P versus 1 by T. Okay, can you plot this graph? I'm waiting for your answers. I'm looking at your chats. P versus 1 by T. What do you think the nature of the graph should be? P versus 1 by T. P versus 1 by T. What should be the nature of the graph? Everyone in the chats. Quickly, everyone. P versus 1 by T. Have a look, guys. Have a look. Pressure you're plotting right now along y-axis. Along x-axis, you're not plotting temperature. You're plotting 1 by T. Correct? 1 by T. The basic equation says P is equal to K multiplied by T. This is the basic equation. Now you tell me whether I want T over here or I want 1 by T. What do you think? Do I want T or 1 by T? Do I want T or 1 by T? I want 1 by T. So can I convert this equation in different format? P is equal to K divided by 1 by T. This T can come up. The equation remains unchanged, right? Now this P you are plotting along y-axis is equal to K divided by 1 by T. 1 by T you are plotting along x-axis. Whenever you see two variables inversely proportional to each other, the nature of the curve will be rectangular hyperbola. So it's going to be hyperbola like this. Simple, basic, right? Simple, basic. Perfect. One homework question I'm giving you, but you are not going to solve the question right now. The way you answered the question in the last session in the comment section, in the similar way, the question which I'm going to give you as the homework, tell me the answer of that question in the comment section afterwards. Not now. Afterwards, when the video ends, in the comment section. The question is like this. The question is like this. I'm plotting a graph between pressure versus temperature in Kelvin. This is one graph, one more graph, one more graph. V1, V2, V3. Option A is saying that V3 is greater than V2, which is greater than V1. Option B says V3 is less than V2 is less than V1. Option C says V3 is equal to V2 is equal to V1. Do tell me the answer of this particular question in the comment section at the end of the session, not now. At the end I'm asking, okay? At the end. Perfect. Now guys, there is one more gas law which I would want you guys to remember. That's the simplest among all. That's called as Avogadro's law. That's called as Avogadro's law. What this Avogadro's law is all about? Avogadro's law states that volume of the gas is directly proportional to number of moles. When volume of the gas is directly proportional to number of moles. Volume of the gas is directly proportional to moles when pressure and temperature of the gas is kept constant. This is the simplest statement, right? You can take the proportionality out, there will be a constant K. V is equal to K multiplied by N. If I ask you what should be the value of K, you know the ideal gas equation says that V is equal to N R T divided by P. Absolutely. Now as per this basic equation, V is equal to K multiplied by N. Now compare the things. This is V, this is V, this is N, this is N. That means this K has to be equal to RT divided by P. So this constant K is equal to RT divided by P. K is equal to RT divided by P. Remember this thing as well. And from this particular equation, what can I get? I can get one more equation. V1 divided by V2 is equal to N1 divided by N2. This is one more equation which we are going to use in the questions. Right? Yes? Simple and basic at the same time. And the way we plotted different graphs, in the similar way you can plot different graphs for this particular law as well. The choice is all yours. Whatever graph you want to plot, you can do that. For example, the simplest among all, volume versus moles. Volume you are plotting along y-axis. This is y. Moles you are plotting along x-axis. This is x. So this is m. Y is equal to mx. Simple. Right? Perfect. So till now we are done with 4 gas laws. We are done with 4 gas laws. Guys, I'm teaching you the most important concepts, right? This series is basically top 50 important concepts, out of which these were 4 important concepts which I gave you, right? We are going to see the problems in a while. Just have a look. Before looking at the problems, have a look. I'm damn sure you must have studied something called as ideal gas equation. Ideal gas equation, right? Ideal gas equation is simple. PV is equal to nRT. This is your ideal gas equation. PV is equal to nRT. Correct? PV is equal to nRT. Yeah? PV is equal to nRT. This is your ideal gas equation. Now, if I ask you, what is this R over here? This R is something which you call as universal gas constant. This R is something which you call as universal gas constant. And this R has got certain values. This R has got certain values. Number 1, 8.314 joules per Kelvin per mole. Or to calculate, for the calculation purpose, just to reduce the calculations, instead of 8.314, you can use 25 by 3. right? Similarly, you can use the value 0.0821 atm liter per Kelvin per mole. atm liter per Kelvin per mole. Or in the calculation, for the calculation purpose, you can use the value 1 by 12. Or similarly, there is one more value, which is 1.98 calories per Kelvin per mole. Or for the calculation purpose, you can take the value 2 exactly. Now, this universal gas constant R, its value depends on the units of pressure and temperature. Sorry, its value depends on the units of pressure and volume. The universal gas constant, its value depends on the units of pressure and volume. In this particular chapter, we would need these two values exactly, right? This is the value of R as per SI system. This is the value of R as per SI system. Now, you must be thinking whether there is one more form for ideal gas equation or not. There is one more form for ideal gas equation as well. That's what we call as density form of ideal gas equation. That's what we call as density form of ideal gas equation. Now, what this density form of ideal gas equation is all about? My dear students, few minutes back I told you, PV is equal to nRT. This is the general form. Can I write PV is equal to, what is N? Number of moles of the gas. Can I say it's going to be given mass of the gas in grams divided by molar mass of gas? This is R, this is T. Simple, right? Now, if you take M here and V here, it's going to be Pm is equal to W divided by V. This is R and this is T. Perfect. So this is going to be Pm is equal to mass by volume is density. So this is dRT. This equation is something which you call as density form of ideal gas equation. So frequently I'll be using this equation as well in the questions. Pm is equal to dRT. Pm is equal to dRT. This equation is called as the density form of ideal gas equation. Now you tell me in the chats whether everything is clear till here or not. Yes or no? Someone is asking what is the difference between real gas and ideal gas. Just wait for it. I'm coming to that only. Tell me in the chats quickly whether this is clear to everyone or not. Yes or no in the chats with the thumbs ups. Let me know in the chats with the thumbs ups, everyone, whether it's super duper clear to everyone or not. Guys, tell me in the chats with the thumbs ups if it is clear to everyone. Simple, right? Let's see what kind of questions can be asked. What kind of other questions can be asked? Let's see. This is your NEET 2021 question. You are going to tell me the answers. Pressure versus volume. Pressure versus volume. Pressure versus volume. Pressure versus volume. Tell me quickly. Is it a straight line? No, it was the hyperbola, right? It was the hyperbola, correct? So either the answer is C or it's D. Now look at the temperature, 600, 400, 200. 200, 400, 600. And we saw a few minutes back, the graph which used to be at the top, that was having more temperature basically. Few minutes back only we saw, right? So what exactly should be the answer of this question? Everyone. Of course, guys, you all are perfectly right. It's going to be option C, done and dusted, right? Done and dusted. Okay, one more question. One more question I'm going to give you. Just a second. Just a second. NEET 2018. NEET 2018. Gas in a cylinder is maintained at 10 atm pressure. The pressure of the gas initially is 10 atm. So P1 is equal to 10 atm. Correct? The temperature of the gas is maintained at 300 Kelvin. T1 is equal to 300 Kelvin. Right? The cylinder will explode if the pressure of the gas goes beyond 15 atm. The cylinder will explode if the pressure of the gas goes more than 15 atm. So maximum pressure which the cylinder can withstand, that's given to me as 15 atm. Let's assume when the pressure of the gas reaches 15 atm, the temperature of the gas is T2. We have to calculate this T2. Do you remember any relation wherein all these terms are involved? I gave you one relation a few minutes back. P1 by T1 is equal to P2 divided by T2. Correct? What is P1? 10. What is T1? 300. P2? 15. T2, you need to calculate. So from this, can't you calculate the value of T2? Done and dusted, right? So I can see majority of the people are coming up with option C. So if majority is saying option C, that means option C has to be the answer. Yes. One more question, quickly, give it a try. Quickly, everyone. Look at this question carefully. A 2.24 liter cylinder containing oxygen at 1 atm and 273 Kelvin. 1 atm and 273 Kelvin means STP condition. So the gas is present at STP. If the gas is present at STP, can you tell me how many moles of the gas will be there? Given volume in liters divided by 22.4. Given volume in liters divided by 22.4. So we have got basically 0.1 moles of the gas initially. Initially in the container, we have got 0.1 moles of the gas. The pressure of the gas was kept as 1 atm. Correct? Now, as per the question is concerned, let's say we have got a container. That container contains 0.1 moles of the gas, kept at 1 atm pressure. Now, suddenly, a hole got established in the container. Suddenly, a hole got created in the container. Due to the hole, there was a leakage. Some of the gas came out of the container. Some of the gas came out of the container due to the leakage. But this leakage was fixed after some time only. The leakage was fixed after some time only. Now, after the leakage, let's assume there are N2 moles of the gas present in the container. But now the pressure of the gas, it dropped. It dropped from 1 atm to 570 mm of Hg. 570 mm of Hg. What do we need to calculate? The number of the moles of the gas escaped. Understand this question carefully. How many moles of the gas escaped? Initially, I had N1 moles. Now, some gas came out of the container. Now, there are N2 moles of the gas left in the container. Kept at pressure 570 mm of Hg. But if you look at the question carefully, here the pressure is in atm. Here the pressure is in mm of Hg. So, I have to convert this mm of Hg into atm, right? I have to convert mm of Hg into atm. We know 760 mm of Hg is equal to 1 atm. Correct? So 1 mm of Hg is equal to 1 divided by 760 atm. Simple unit conversion I'm using. So 570 mm of Hg will be equal to 1 upon 760 multiplied by what? Multiplied by 570 atm. The value will come out to be 57 divided by 76 atm. So this is the final pressure of the gas in atm. So P2 value is equal to how much? 57 divided by 76 atm. Correct? Correct? Someone is saying, how did I calculate the number of moles? I was given with the volume of the gas at STP. Given volume divided by 22.4 liters. Mole concept, right? So people, P1, N1, P2, N2. So can I use the equation? P1 divided by P2. P1 divided by P2 is equal to N1 divided by N2. So P1 we know, P2 we know, N1 we know. From here I can calculate N2. So N2 value I can calculate from here. What was this N2? What was this N2? N2 represents the number of moles of the gas left in the container. Initially I had 0.1 moles. Now there are N2 moles of the gas left in the container. So how many moles of the gas escaped? So if I ask you, how many moles of the gas escaped? How many moles of the gas escaped? It's going to be equal to, initially I had N1 moles. I'm left with N2 moles. So N1 minus N2 is going to be the answer. N1 value you know, N2 you will calculate from here. N1 minus N2 is going to give you the answer. Let me know quickly in the chats if you can solve this sort of equation from now onwards, if it comes. Quickly everyone, quickly. Quickly everyone. Quickly everyone. One more question I'm giving you. Then I'm going to one more concept. The density of a certain gaseous oxide. So basically we have got a container containing some gaseous oxide. It can be nitrous oxide, whatever oxide, carbon dioxide, whatever, okay. So we have got a gaseous oxide in the container. Right? The pressure of the gaseous oxide is given to us. As 1.5 atm. Okay. Temperature of this same gaseous oxide is given to me as 20 degrees centigrade. 20 degrees centigrade means 293 Kelvin. Temperature of the gas oxide is given, right? It is mentioned that the density of gaseous oxide, is same as that of density of oxygen. It is same as that of density of oxygen. And this oxygen, it's kept at 4.5 atm and 10 degrees centigrade. So pressure of oxygen here, it's equal to 4.5 atm. And temperature of O2 is 10 degrees centigrade, that means 283 Kelvin. Perfect. What do I need to calculate? Calculate the molar mass of the gaseous oxide. Molar mass of the gaseous oxide. Molar mass of the gaseous oxide I need to calculate. Do you know the molar mass of O2? Yes, molar mass of O2 is 32 grams per mole. Right? Now which equation you will be using in this one? Few minutes back only I gave you the density form of ideal gas equation. PM is equal to DRT, right? I gave you one equation, PM is equal to DRT. So can I eliminate D from here? D will be equal to PM divided by RT. D is equal to PM divided by RT. Now it's mentioned in the equation, the density of gaseous oxide is same as that of density of O2. Instead of density of gaseous oxide, can I write pressure of gaseous oxide, molar mass of gaseous oxide, or temperature of gaseous oxide? So pressure of gaseous oxide, molar mass of gaseous oxide divided by R, and it's going to be temperature of gaseous oxide is equal to density of O2, pressure of O2, molar mass of O2 divided by R, and its temperature of O2. So R and R gets cancelled out. R and R gets cancelled out. Dear students, pressure of gaseous oxide is given. Temperature of gaseous oxide is given. Temperature of O2 is given. Molar mass of O2 you know, right? Molar mass of O2 you know. Pressure of O2 is also given. So one equation, only one unknown. One equation, one unknown. Put the values, get the answer. Put the values, get the answer. So the answer comes out to be 99.3 grams per mole. Let me know once in the chats with the thumbs ups if every single thing is clear. Quickly. Let me know quickly in the chats if every single thing is clear to everyone. Everyone. Let me know quickly in the chats with the thumbs ups if every single thing is clear to everyone. Yes? Quickly, people, quickly. Quickly, let me know in the chats with the thumbs ups. With the thumbs ups, everyone. Perfectly done. Okay. Can you tell me the answer of this particular question? Density versus temperature. Density versus temperature. What should be the graph? What should be the graph? You know, PM is equal to DRT. PM is equal to DRT, right? Perfect. Can I say PM divided by T multiplied by R is equal to D? D is equal to PM divided by RT, right? What do you see exactly? Density and temperature. Are these directly proportional or inversely proportional? These are inversely proportional. Whenever you need to plot a graph between two variables which are inversely proportional, the nature of the graph is rectangular hyperbola, right? So this cannot be the answer, right? That's something we were supposed to check. Which of the following graphs is not correct? So this graph is not correct. It has to be a hyperbola. It has to be a hyperbola. It has to be a hyperbola. So first one is correct. So second one is incorrect. You were supposed to select the incorrect option, guys. Yes? Perfectly done. Perfectly done. So gas laws we are done with, right? We are done with gas laws. Now, there is one more important concept in the states of matter chapter, that is Dalton's law of partial pressure. That is Dalton's law of partial pressure. I am going to summarize this Dalton's law of partial pressure in a very few statements so that you can solve all the questions. Okay? Understand what this Dalton's law of partial pressure says. It's a common sense basically, and you are going to answer everything. Imagine this is the container. Imagine this is the container. Imagine in this container there are three gases, or let's keep it as two gases. Let's imagine there are two chemically non-reacting gases present in the container. Let's imagine there are two chemically non-reacting gases present in the container, gas A and gas B. That means there will be few molecules of gas A as well as there will be few molecules of gas B in the container as well. There are molecules of gas A as well as gas B in the container, right? Molecules of gas A as well as gas B in the container. Perfect. Now, dear students, let's assume the total volume of the container, or leave the total volume of the container aside. You tell me, how many gases are there in the container? There are 2 gases present in the container. Can I say something like this? Can I say in this particular container right now we have got a mixture of gas? We have got a gaseous mixture. We have got a mixture of A and B. Let's assume the total pressure of the whole gaseous mixture is PT. PT represents the total pressure of the whole gaseous mixture. Now you tell me whether the total pressure of the gaseous mixture will be only due to A, only due to B, or both will contribute towards the total pressure. What do you think? Since there are 2 gases present in the container, so both the gases will contribute towards the total pressure. And Dalton's law says that total pressure of the mixture is the sum of contribution made by each. Right? Let's assume the contribution made by gas A towards the total pressure is PA. Contribution made by gas B towards the total pressure is PB. So it's evident, right? Total pressure of the gaseous mixture will be the sum of contributions made by each gases. And contribution made by each gas is something which you call as partial pressure. So this PA is something which I call as partial pressure of A. This is called as partial pressure of A. Similarly, this is called as partial pressure of B. Correct? Simple. This is one thing which I want you guys to remember. Right? Now people, one more thing. I can calculate this total pressure in a different way as well. Total pressure is equal to PA plus PB. You can write it as NA plus NB multiplied by RT divided by V. This is one more way of calculating the total pressure. Na means number of moles of gas A in the container. Nb means number of moles of gas B in the container. T is the temperature of mixture. V is the volume of the gaseous mixture. Correct? This is one more thing. Which you need to take a note of. At the same time, if they ask me to calculate the partial pressure of A, to calculate the partial pressure of B, matlab contribution made by A towards the total pressure, contribution made by B towards the total pressure. How do I do it? It's simple. It's going to be total pressure of the mixture multiplied by mole fraction of A in the gaseous mixture. Similarly, total pressure of the mixture multiplied by mole fraction of B in the gaseous mixture. Correct? You can write it like this as well. Total pressure of the mixture multiplied by mole fraction of gas A means moles of A in the container divided by total moles present in the container, Na plus Nb. This is going to be equal to total pressure of the mixture multiplied by mole fraction of B means number of moles of B in the container divided by total moles present in the container. These are few general results which I would want you guys to remember. Now, what kind of questions are asked? Okay, before dealing with the questions, let me tell you one more concept so that you can visualize it properly, so that you can utilize it properly in the questions. Understand what I'm going to say? Let's assume this is the container. Imagine things and understand, properly understand. Let's say there is gas A and gas B in the container. Let's assume the number of moles of gas A in the container are 3, number of moles of gas B in the container are 7. Okay? Let's say the total pressure of this mixture over here is 10 atm. If I ask you whether this 10 atm, is it only due to A? No. Is it only due to B? No. Both the gases would have contributed towards the total pressure. For sure, right? What is the contribution made by gas A? That means I'm asking you about the partial pressure of A. It's equal to total pressure of the mixture multiplied by mole fraction of A. Mole fraction of A means moles of A divided by total moles present in the container, which is 7 plus 3, 10. The value comes out to be 3 atm. This is the contribution made by gas A towards the total pressure, which is what I call as partial pressure. Right? Similarly, what about the partial pressure of B? It's equal to total pressure of the mixture multiplied by mole fraction of B. Mole fraction of B means moles of B in the container divided by total moles. The value comes out to be 7 atm. So the total pressure of the mixture was 10 atm. Out of 10 atm, 3 atm is contributed by A and 7 atm is contributed by B. So if you take the sum of the two, 7 plus 3, that has to be equal to 10. Now, there is one thing which I would want you guys to analyze, understand. If I ask you, what was the ratio of the moles of the gases in the container? What was the ratio of the moles? Ratio of the moles was 3:7. What is the ratio of partial pressure? Ratio of partial pressure is also 3:7. Can I generalize a simple statement from now onwards? Whatever will be the ratio of the moles of individual gases present in the container, same is going to be the ratio of their partial pressures. Yes? Let me know in the chats with a thumbs up if you got it. Quickly. Let me know in the chats with the thumbs ups if you got it. Everyone, quickly. Quickly, everyone. And I can see everyone has not liked the session yet. So please do like the session. Do subscribe to this particular channel as well. Tell me yes or no in the chats whether every single thing is very clear. Everyone. Then only I can move ahead. Perfect. Let's solve one question from this concept so that you can understand it properly. Okay? One question we are going to solve from this. One question I'm going to give you, okay? The question is like this. The question is, equal masses of O2 and CH4 are enclosed in the vessel. At a total pressure of 10 atm. Calculate the partial pressure. Calculate the partial pressure of O2. Can you do it? Can you do this one? It's a simple one. Have a look. See. There's a container. This is the container which I'm talking about. This is the container, right? In this container, we have got two gases. One is O2 and one is CH4. In the same container, we have got equal masses of both the gases. Let's assume there are X grams of O2 in the container. That means there are X grams of CH4 in the container as well. The total pressure of the mixture is also given to me. Total pressure of the mixture is how much? 10 atm. 10 atm. What are we supposed to calculate? We are supposed to calculate the partial pressure of O2. So I can say the partial pressure of O2. Is equal to. The partial pressure of O2 is equal to, as per the formula, total pressure of the mixture multiplied by mole fraction of O2. Total pressure of the mixture is 10 atm multiplied by mole fraction of O2 means number of moles of O2 in the container divided by total moles, which is number of moles of O2 plus number of moles of CH4. Correct with this? Now people, number of moles of O2 and number of moles of CH4 you have to calculate. Tell me how many moles of O2 you have in the container. It's equal to given mass of O2 in grams divided by molar mass of O2, that's 32 grams per mole. Number of moles of CH4 will be equal to given mass of CH4 in grams divided by molar mass of CH4. So you got the moles. So it's going to be equal to 10 multiplied by number of moles of O2 present in the container. That's X divided by 32 whole divided by number of moles of O2. That's X divided by 32 plus X divided by 16. X everywhere common. Take it out. X gets cancelled. So solve it and get the partial pressure of O2 present in the mixture. Let me know quickly in the chats if it is super clear to everyone. Let me know quickly in the chats with the thumbs ups, people. Everyone. Quickly let me know. And tell me the answer of this question which was asked in NEET 2022 from the same concept. Tell me the answer of this particular question in the chats quickly. Quickly guys, quickly. It's simple. Quickly guys, everyone in the chats. Which one is not correct mathematical equation for Dalton's law? The first one is correct, you know it, right? Total pressure is the sum of partial pressures. The second one is also correct. Partial pressure of 1 is N1 RT by V. Partial pressure of 2 is N2 RT by V, N3 RT by V. This is also correct, right? Partial pressure of a gas is equal to total pressure multiplied by mole fraction of gas. This is also correct. So there is only one option which is left out, that's option D. So option D has to be the answer of the question, right? It's a simpler one. I'm sure you can easily solve this one. Okay, moving on to one more concept. That is Graham's law of effusion and diffusion. Graham's law of effusion and diffusion. This is one more important concept which you have to master basically. Okay. So people, what this Graham's law of effusion diffusion is all about and what kind of things we have to relate and understand. First of all, what is effusion? What is effusion? See guys, a very simple concept this is. Let's say this is the container. In this container, we have got a gas. This is the ideal gas present in the container, for example. Okay. Now, you know, these gas molecules, they'll be always in continuous random motion. Correct? They will be in continuous random motion. So, if they are in continuous random motion, that means this gas will be having some pressure. Right? This gas is under pressure right now. Perfect. Now, if you introduce a hole over here, let's say there is a small hole in the container. Let's say this is the hole. Right? The hole got developed in the container. Due to the presence of the hole, can I say some of the gas will come out of the container? Absolutely. Some of the gas will come out of the container. The escaping out of gas molecules, the escaping out of gas molecules, the escaping out of gas molecules from the hole when the gas is under pressure. When the gas is under pressure, this phenomenon is called as effusion. This phenomenon is called as effusion. So basically I took a container, right? I took a container. In the container I've got the gas. Now suddenly a hole got developed in the container. Some of the gas is coming out of the container. The escaping out of the gas molecules through the hole when the gas is under pressure, that's what you call as effusion. That's what you call as effusion. Now at the same time, you got to know what is effusion. Now what is diffusion then? What is diffusion then? How do you define the term diffusion? Now you know, outside this container there is atmosphere, and atmosphere contains different gases. It contains a mixture of gases. Atmosphere, it contains a mixture of gases, right? Now the gas which has come out of the container, I call that gas as escaped gas or effused gas. Now this effused gas, spontaneously it's going to intermix with the atmosphere to form a homogeneous mixture. The gas which has come out of the container, spontaneously it's going to intermix with the atmosphere to form the homogeneous mixture. And the intermixing of the gas, of the effused gas, which is spontaneous. The intermixing of the effused gas, which is spontaneous with the atmosphere, to form a homogeneous mixture. That's called as diffusion. So first the gas comes out, and later on the gas which comes out, that spontaneously intermixing with the atmosphere to form the homogeneous mixture. That's what I call as diffusion, right? Number one. Number two, I'm going to define something called as a rate of effusion. Rate of effusion. There are many ways by means of which you can define this rate of effusion. Few ways I'm going to write here. Rate of effusion. The first way in order to define the rate of effusion is, it is defined as volume of the gas effused, volume of the gas effused divided by time taken. Divided by time taken. This is one way by means of which you can define rate of effusion, right? Whatever volume of the gas is coming out divided by time taken. Similarly, you can define it in terms of moles as well. I'll say moles of the gas effused, moles of the gas effused divided by time taken, right? This is one more way of defining the rate of effusion, right? Volume of the gas effused divided by time taken. Similarly, number of moles of the gas effused, that means I'm talking about those moles of the gas which got out of the container, divided by time taken. This is one more way of defining the rate of effusion, right? There is one more way in terms of distance, in terms of pressure drop. A lot of ways are there basically, but I basically will be dealing with these two here, okay? Now, since you got to know, you got the idea of what this diffusion is all about, what is effusion is all about. Now, there is something important, that's Graham's law of effusion. That is Graham's law of effusion. What does Graham's law of effusion says? What does Graham's law of effusion says? Okay, I'm giving you one analogy over here. For example, you have got a container. You have got a container, right? In the container, there is a gas, right? Now, you are going to put one hole in the container. The gas is going to come out. Can you tell me, if the gas is heavy, will the rate of effusion be more? Will the speed of coming out of the gas be more or less? Tell me. If the gas is heavy, will the rate of effusion, the velocity with which the gas comes out of the container, will that be more or less? Quickly. Quickly. Will it be more or less? It will be, of course, less. Graham's law of effusion simply tells you that a rate of effusion is inversely proportional to square root of molar mass of the gas. More the molar mass of the gas, lesser will be the rate of effusion. Lesser the molar mass of the gas, more will be the rate of effusion. Simple and basic. Simple and basic. Two results we have to remember, that's all. Two results we have to remember, that's all. Now understand the results and we will apply them in the questions. Rest, let's not go into a lot of details. Let's say this is one container which we have. This is one more container which we have. Okay. This particular container contains gas A. This particular container contains gas B. Molar mass of gas A I'm denoting with Ma. Molar mass of gas B I'm denoting with Mb. I'm assuming both the gases are present at same pressure and temperature. Both the gases are present at same pressure and temperature. This is something which I'm assuming. Okay. Nowadays students, let's assume some of the gas A came out of the container. Let's say VA ml of gas A came out of the container in TA seconds. Similarly, let's assume VB ml of gas B came out of the container in TB seconds. Now, what we are going to do? Effusion is happening here also. I need to compare the rates of effusions. How I'm going to compare it? I told you a few minutes back only. Rate of effusion is inversely proportional to square root of molar mass, right? You can say rate of effusion of A divided by rate of effusion of B is equal to, it's going to be under root of molar mass of B divided by molar mass of A. Simple, right? I'm just comparing the rates of effusions of these two gases. Now you tell me, rate of effusion of A. Can I write, instead of rate of effusion of A, can I write volume of A coming out of the container in time Ta? whole divided by rate of effusion of gas B, volume of B coming out of the container in time TB. Absolutely. Or if you do not want to write it in terms of volume, you can write it in terms of moles as well, right? Rate of effusion of A, I can say moles of A coming out of the container in time TA, whole divided by moles of B coming out of the container in time TB. Perfect. This is one equation which you guys are going to use in the questions, right? This is how you are going to compare the rates of effusions of two gases which are present at same pressure and temperature. Simple. Correct? Let me know once in the chats. If this result is clear, then only I can move on to the questions. Quickly, everyone, quickly. Quickly tell me. Is it super clear to everyone? Let's exactly see how it's to be applied. Okay? Or before showing you the application of this particular result, let me tell you one more thing. This is valid when the pressure and temperature of both the gases is same. Correct? Now, dear students, if the pressure of both the gases is different, let's say the pressure of this gas is PA, let's say the pressure of this gas is PB. More the pressure of the gas, more will be the rate of effusion. More the pressure of the gas, more will be the rate of effusion. So, I can say something like this as well. Rate of effusion, it's directly proportional to pressure, inversely proportional to square root of molar mass. More the pressure of gas, more the rate of effusion. And one thing already we know. Now, I've taken two gases. Let's say their temperature is same, but the pressure is different. Now, I want to compare the rates of effusions of two gases. It's going to be Ra divided by Rb is equal, this is going to be Pa, this is going to be Pb, under root of Mb divided by Ma. Under root of Mb divided by Ma. Now, instead of this particular rate of effusion of A, you can write volume of A coming out of the container in time Ta. Instead of rate of effusion of B, volume of B coming out of the container in time Tb. You can write it in terms of moles as well. Moles of A coming out of the container in time Ta. Moles of B coming out of the container in time Tb. This is one more result. This is one more result. This is one more result. But this particular result which I mentioned here, it is valid when the pressure of both the gases is different. When the pressure of both the gases is different. This is how you compare the rates of effusions of two gases when pressure of the two gases is different. This is when the pressure and temperature of both the gases is same. Let's try to do a few questions so that you can understand it. Right? Let's try to do a few basic questions so that you can understand it. Okay. First question on your screen. Give it a try. Let me know once in the chats if it is clear. Once let me know in the chats if everything seems clear. With the thumbs ups. Everyone. Then only we can solve this question. Quickly guys, quickly. Quickly, everyone. Everyone, let me know quickly. All set? Okay. Let's try to give it a try. Let's see how this sort of a question is to be solved. How much time more? I'll take half an hour more, okay? Just be with me. Half an hour more I'll take. Alright, people. As per this particular question is concerned, a sample of SO2 gas escapes through a hole in 122 seconds. How long will it take for O2 to effuse the same volume under similar conditions? What it means exactly? So basically you are taking two gases. This is one gas. This is one more gas here. Right? You have taken two containers. The first container contains SO2 gas. The second container contains O2 gas. First container contains SO2, second one contains O2 gas. Right? Both the gases are present under similar conditions. That means pressure and temperature of both the gases is kept same. Okay? As far as the question is concerned, a sample of SO2 escapes through the hole. Let's assume V ml of SO2 gas is coming out of the container in time 122 seconds. Let's assume V ml of SO2 gas is coming out of the container in 122 seconds. Now it's asked It's asked, how long will it take for O2 gas to effuse the same volume? How long will it take for the O2 gas to effuse the same VML under similar conditions? How long will it take for O2 to effuse the same volume under similar conditions? Is the pressure temperature same? Absolutely, pressure temperature is same. If I ask you to compare the rates of effusions, can you do that? Can you do that? It's simple. I'll say rate of effusion of SO2 divided by rate of effusion of O2 has to be equal to under root of molar mass of O2, and this is going to be molar mass of SO2 here. Correct? Rate of effusion of SO2, I can write volume of SO2 coming out of the container divided by time taken by SO2, whole divided by rate of effusion of O2, volume of O2 coming out of the container divided by time taken by O2. Now it's very simple. If you just need to compare these two terms, it's going to be equal. How much volume of SO2 is coming out of the container? VML. How much volume of O2 is coming out of the container? VML, right? So it's going to be under root of molar mass of O2 is 32 grams per mole. Molar mass of SO2 is 64 grams per mole is equal. It's going to be TO2 divided by TSO2. TO2 divided by TSO2. TSO2 is 122. The answer finally is going to be equal. TO2 is equal. It will be 122 divided by root 2 seconds, or you can write it like this, 61 root 2 seconds. So this is the time taken. This is the time taken by O2 to effuse the same VML as was effused by SO2. Is it clear? Let me know quickly in the chats with the thumbs ups, everyone. Everyone, let me know quickly in the chats if it is super clear to everyone. Let me know quickly in the chats with the thumbs ups. Everyone. Quickly. Quickly, guys. Quickly. Quickly. Okay, one more question. One more question. One more question. Look at the question carefully, people. Look at the question carefully. Understand, I'm not going to use any formula, I'll use just common sense to solve this question. As far as the question is concerned, we have got two gases, gas A and gas B. We have got two gases, gas A and gas B. 50 ml of each gas A and B takes 150 and 200 seconds respectively to effuse out. So it's mentioned in the question, the volume of gas A which is coming out of the container, that's 50 ml. Similarly, volume of gas B which is coming out of the container, that's again 50 ml. That's again 50 ml, right? 50 ml of gas A is coming out of the container, and similarly 50 ml of gas B is coming out of one more container, right? Now as per the question, 50 ml of gas A is coming out in 150 seconds. So time taken by gas A to come out is 150 seconds. Time taken by gas B to come out is equal to how much? Is equal to 200 seconds, correct? 50 ml of gas A is coming out of the container in 150 seconds. In the similar way, 50 ml of gas B is coming out of the container in 200 seconds. Now you tell me one thing. See, same volume of both the gases is coming out. Same volume of both the gases is coming out. But this gas A, it's taking lesser time to come out. That means the speed with which the gas A will be coming out, that will be more. The speed with which the gas A will be coming out will be more. What does that mean? That means the rate of effusion of A is more than that of rate of effusion of B, right? But you know, rate of effusion is inversely proportional to square root of molar mass. So, more the rate of effusion, lesser the molar mass. If rate of effusion of A is more, that means molar mass of A has to be less than that of molar mass of B, right? What is the molar mass of B? Molar mass of B is 36 grams per mole. So, molar mass of A has to be less than 36. And there is only one option which is less than 36. That's option A. Done and dusted, right? Got it? And dear students, you can just use the formula as well. You can use the formula as well. You can solve the question like this as well. RA divided by RB is equal to under root of MB divided by MA. Then instead of this RA, you can write VA divided by TA. Instead of RB, you can write VB divided by TB. then accordingly you can get the same answer. Let me know once in the chats quickly if it is clear. Reshma is saying better is to use formula. It's completely your wish what to do. It's completely your wish whether you want to use the formula or solve the question directly. Perfectly done. Let me know in the chats quickly, guys. Everyone with the thumbs ups. Or if you want me to stop the session, I can do that as well. Or else, I want to see some energy in the chats. Otherwise, there's no fun teaching you. Yeah? And a lot of people have not subscribed to the channel yet. Why is that? Something. That's it. Is this much? Is this the energy? Is that all? That's it? Is that it? You guys are sleeping, I'm damn sure. I want the chat box to move fast, very fast. Then only I can feel that you guys are actually with me. And continuously, I don't want the chat box to stop now, okay? Once you stop the chats, I'll stop the session. Just remember that. Look at one more question then. Look at one more question. Look at one more question. Or let me give you this question as one more homework. This is the second homework. Let me know the answer of this particular question also in the comment section afterwards. Comment section. Okay. So this was about Graham's law of effusion and diffusion. Now people, there is one more important concept from the same chapter, that is, I don't want the chat box to stop at all, okay? Remember that. There is one more concept, one more important concept from which question comes, that is compressibility factor. Do you know what is the difference between real gas and ideal gas? If I particularly talk about the ideal gas, between the ideal gas molecules, there will be no force of interaction. There will be no force of attraction or repulsion between the ideal gas molecules. But between the real gas molecules, there will be force of attraction or repulsion. That is the major difference. That is the major difference. Between the ideal gas molecules, there is no force of interaction. But between the real gas molecules, there is force of interaction. Major difference. One more thing. The size of the real gas molecules is more than that of size of the ideal gas molecules. Or in other words, I can say the size of the ideal gas molecule, that is negligible as compared to the volume of the container in which it is kept. Imagine it like this. Let's say this is the container. Let's say this is one more container. Let's say in this particular container we have got ideal gas. Here we have got real gas. These are the real gas molecules. Sorry, these are the ideal gas molecules. But these are the real gas molecules. Look at the size. The size, the actual volume of the ideal gas molecule can be neglected as compared to the volume of the container in which it is kept. But the actual volume of the real gas molecule cannot be neglected as compared to the volume of the container in which it is kept. Two major differences. Size of the ideal gas molecule is negligible. That means, what does that mean? That means the actual volume of the ideal gas molecule can be neglected as compared to the volume of the gas, as compared to the volume of the container in which it is kept. But the size of the actual volume of the real gas molecule cannot be neglected as compared to the volume of the container in which it is kept. Now, what about this compressibility factor? Compressibility factor is denoted by Z. Compressibility factor is denoted by Z. This compressibility factor is going to let you know how much the real gas has deviated from the ideal behavior. Or in short, in simple words, let me make it clear like this. This compressibility factor is going to let you know whether the gas inside the container, whether it is a real gas or ideal gas. This compressibility factor Z, it's going to let you know whether the gas in the container, whether it is a real gas or ideal gas. And how exactly? There are few ways to calculate this compressibility factor for a gas. One is PV divided by nRT. This is one way to calculate the compressibility factor of the gas. Pressure of the gas, volume of the gas, moles, RT. Similarly, one more way, PM divided by DRT. This is one more way to calculate the compressibility factor of the gas. In the similar way, I can write it as V naught divided by VI. V naught is called as observed volume. Observed volume. VI is called as the ideal volume. Now let me make you understand all these things clearly. Let me make you understand all these things clearly. Now be with me, understand properly what I'm going to say. For example, I'm going to write something like this. Let's say you have got a gas in the container. You have no idea whether the gas is real or ideal. You have no idea whether the gas is real or ideal. But you know the pressure of the gas. You know the volume of the gas. You know the temperature of the gas as well. For example, you know all these things. Yeah? You know all these things. Now, dear students, let me calculate the compressibility factor for this gas, Z. And compressibility factor Z is equal to PV divided by nRT. I'm assuming you know the pressure, you know the volume, you know the temperature, you know the moles present in the container. Now, after putting all the values here, if by chance the value of Z comes out to be 1, if the value of compressibility factor for this particular gas, if it comes out to be 1, that means if Z is equal to 1, that means PV is equal to nRT. So that means the gas which is there in the container, it is following the ideal gas equation. That means the gas which is there in the container, that is the ideal gas. Correct? That is the ideal gas. And people, do remember, if the value of Z for the same gas is not equal to 1, if the value of Z for the same gas is not coming out to be 1, that means PV is not coming out to be equal to nRT. So the gas in the container right now will be called as the real gas. I won't be calling it as the ideal gas. I'll be calling it as the real gas. Correct? If Z value is 1, if the compressibility factor for the gas is 1, it's ideal. If the compressibility factor is not equal to 1, it's going to be real. Now there are two things which you need to remember. If the value of Z for the gas in the container is less than 1, first of all, the gas is real. And this real gas, we say, in this real gas, attractive forces dominate. Which forces dominate between the gas molecules? Attractive forces dominate between the gas molecules. When the Z value for the gas comes out to be less than 1, first of all, the gas has to be real. And in this real gas, the attractive forces dominate. Second term, if the value of Z is coming out to be greater than 1 for the gas is again real, but right now, force of repulsion dominates between the gas molecules. Force of repulsion dominates between the gas molecules. This is the question which is asked. This is the question which is asked. Z value less than 1, Z value greater than 1. Okay? Perfect with this? You want to see the question? You want to see the question which is asked from this? This is your NEET 2019 question. This is your NEET 2019 question. Or before solving this question, let's try to solve one more question. Then I'll come to this question. Okay? Let's solve this one first. Let's solve this one first. Let's solve this one first. 1 mole of gas, N is equal to 1, occupies the volume of 30 liters. Occupies the volume of 30 liters. Temperature of the gas is 273 Kelvin. Pressure of the gas is 1 atm. You have to predict the nature of the gas. You have to predict the nature of the gas. So basically, you'll be calculating the compressibility factor for the gas, which is PV divided by nRT. You know the pressure, you have the volume, temperature, moles, R value, everything, right? So basically, when you put the pressure over here as 1 atm, volume is 30 liters, number of moles is 1, R value is 1 by 12, temperature is 273, this value will come out to be greater than 1. This value after solving will come out to be greater than 1. If this value is coming out to be greater than 1, if this value is coming out to be greater than 1, that means the gas whose parameters are given to you, is that the real gas or ideal gas? That is definitely the real gas. and Z value greater than 1 means which forces are dominating? It is basically the force of repulsion which is dominating between the gas molecules. Clear to everyone? This should be clear to everyone as well. Okay, this should be clear to everyone as well. This is one more question which I would want you guys to give it a try. The density of steam means H2O gas. This is the gas, right? What is the molar mass of this steam? Molar mass is 18 grams per mole. This is its molar mass. The temperature of the gas is 100 degrees centigrade, matlab 373 Kelvin. The density of the gas is 0.6 kilograms per meter cube, right? The pressure of the gas is 10 raised power 5 Newton per meter square, matlab Pascal. What do we need to calculate? We need to calculate the value of compressibility factor. Since you need to calculate Z, which formula you are going to use? Z is equal to PM divided by dRT, right? Z is equal to PM divided by dRT. One mistake you can do here. Pressure is given as per SI system, 10 raised power 5. This is molar mass. The units are in grams. But I have taken pressure as per SI system. So mass also I have to take as per SI system, right? But it's 18 grams. So I'll be converting it into kilograms. So into 10 raised power minus 3. I have to take all the values as per SI system. Density, it's given as per SI system, 0.6 kilograms per meter cube. R value as per SI system, 8.314 joules per Kelvin per mole. Temperature as per SI system, how much that is? 373 Kelvin, right? Put all these parameters here, solve it, get the value of Z. Isn't it simple, guys? Matlab means, matlab is means, meaning. Iska matlab means, this means, iska matlab means, wow. Yeah, matlab is which means, correct, to be more precise. Okay? Now one more thing, guys, one more thing which I would want to add here. That real gas whose Z value is less than 1, we say attractive forces dominate in that gas. And that particular gas in which attractive forces dominate, that means the molecules want to come closer. That means the gas can be compressed easily. You can say this real gas, it is more compressible. It is more compressible than that of ideal gas. Similarly, that real gas in which repulsive forces dominate, the gases do not want to come closer. So it's going to be difficult to compress the gas. You can say this particular gas whose Z value is greater than 1, the gas is less compressible. Less compressible than that of what? The gas is less compressible than that of ideal gas. Okay? So do remember this particular thing as well. Now after this, there is one question and I'm damn sure you can easily solve this one. I'm 100% sure you can easily solve this one. Sir, I have a doubt. If I take a balloon, if I increase the volume by inserting air inside it, pressure and volume increase simultaneously. So do you want to use the Boyle's law there? You cannot use the Boyle's law. Boyle's law is used for a fixed amount of gas in the container. You are continuously blowing the balloon. So gas is continuously going inside the container, inside the balloon. So the gas is not remaining constant. So you cannot use the Boyle's law there. Yeah? Perfect till here? Perfect till here? The question is, a gas at 350 Kelvin and 15 bar has the molar volume 20% smaller than the ideal gas. 20% smaller than the ideal gas. Can you solve it now? So you know, your Z is basically V0 divided by Vi. Right? This term is 20% less than that of Vi. 20% less. So the Z value will be directly less than 1. Z is less than 1 means the gas is real. The gas is real. And if the gas is real, at the same time, there will be attractive forces which will be dominating. Perfect? This is something which you need to Understand as well? Now, one last topic of this chapter, that's van der Waals gas equation. There are few things only which you need to remember about van der Waals gas equation, from which question can easily come. Understand and remember properly. Okay? See guys, first of all, how do we write the van der Waals gas equation? We write it like this. P plus delta P V minus delta V is equal to nRT. Now this delta P is something which you call as pressure correction factor. You call it as pressure correction factor. Delta P is something which you call as pressure correction factor. This delta V is something which you call as volume correction factor. Volume correction factor, right? Now directly I'm going to give you the values. I'm not going to go into the derivation and all. This delta P, which is the pressure correction factor, it is equal to AN square divided by V square. This delta V is equal to N times B. Now this A and B over here, these are called as van der Waals constants. This A and B over here, these are called as van der Waals constants, A and B. Right? A and B are called as van der Waals constants. A and B, these are called as van der Waals constants. Okay? At the same time, the van der Waals constant A, it gives us the idea about the force of attraction between the real gas molecules, between the gas molecules. More the value of A for a gas, more will be the force of attraction between the gas molecules. Similarly, this van der Waals constant B, it gives us this idea about the size of the gas molecules. More the value of B for the gas, more is going to be the size of the gas molecule. More A, more attraction. More B, more size. More B, more size. Okay? Now at the same time, tell me just one thing. If I've got a gas whose A value is more, that means force of attraction between its gas molecules is more. And if force of attraction between its gas molecules is more, that means the gas can be easily liquefied. The gas can be compressed more. The gas can be easily liquefied as well. Right? The gas can be easily liquefied. Similarly, dear students, lesser the value of A, lesser the force of attraction, right? Difficult for the gas to be liquefied, right? As simple as that. Now there is one more thing which I would want to share with you. If you ask me, what is going to be the unit of A? What is going to be the unit of A? You know, your delta P, it is equal to AN square by V square. AN square divided by V square. If I eliminate A from here, A is going to be delta P, V square divided by N square. Right? Now you tell me what are going to be the units of A. Delta P is pressure basically, which is in ATM. Volume ka square means liter ka square divided by mole square. This is going to be the unit of A. This also comes into examination, right? What is the unit of A? Similarly, if you ask me what is the unit of B, what is the unit of B? You know, your delta V is equal to N times B. So B is equal to delta V divided by N. Delta V means volume liter per mole. So liter per mole is basically the unit of B. This is the unit of A and this is the unit of B. As simple as that. Correct? Correct? I hope this is clear to everyone. I hope this is clear to everyone. Now guys, there is one more thing which please take a note of. This B is a constant basically whose value actually is 4 multiplied by 4 by 3 pi r cube multiplied by Avogadro's number. This B is calculated like this. Sometimes you will be given with the radius of the gas molecule and they will ask you to calculate B value. It's 4 into 4 by 3 pi r cube. R is the radius of the gas molecule multiplied by Avogadro's number, which is Na. Yes? Right, people? Okay? So, do remember this particular statement as well. Let me give you one simple question. Let me see if you can answer this question or not. For example, this is a container. It contains gas 1. I've got one more container. It contains gas 2. Okay. Let's say B value for both the gases is same. For both the gases are having B value same. But A value for gas 1 is greater than that of A value for gas 2. A value for gas 1 is more than that of A value for gas 2. Can you tell me which gas occupies more volume? Can you tell me which gas occupies more volume? A or 1 or 2? Gas 1 or gas 2? This is the question. Quickly in the chats. Quickly in the chats, everyone. Which gas occupies more volume? Is it 1 or 2? One or two, quickly. People are saying it's 2. Why is that? See, since B for both the gases is same, so both the gases have got same size. Both the gas molecules have got same size. But A value for 1 is more. That means force of attraction between these molecules is more. If force of attraction is more, that means molecules would have come closer. Volume would have decreased. Volume will have decreased. So volume of gas 1 will be less than that of volume of gas 2. Correct? Okay. This is one question. Let me give you one more question. Tell me the answer of this question. Criteria for the gas to get liquefied easily. Criteria for the gas to get liquefied easily. Option 1, A value should be more, B value should be more. Option 2, A value should be more, B value should be less. Option 3, A value should be less, B value should be less. Option 4, A should be less, B should be more. What is the criteria for the gas to get liquefied easily? Quickly. Quickly, everyone in the chats. Criteria for the gas to get liquefied easily. Quickly, guys, this is something which every one of you should know. See, for the gas to get liquefied easily, remember first of all that gas in which the molecules have got tendency to come closer, or let me make you understand like this. Do remember it from now onwards. More the value of A means more the force of attraction between the molecules. If more is the force of attraction between the molecules, what does it mean? It means the molecules want to come closer. The molecules want to get liquefied. I mean, the gas wants to get liquefied. So the gas is easily liquefied, right? Correct? So that gas in which force of attraction is more between the molecules want to come closer, that gas can be easily liquefied, number 1. Number 2, that gas which has got lesser value of B, lesser size of molecules, that gets liquefied easily too, right? Because of the less repulsions between the electron clouds of the molecules. Okay? So do remember this particular thing. A has to be more, B has to be less. One last thing about this particular chapter. What is that? You are asked certain things. What is the compressibility factor of the gas at a low pressure? Do remember, this question is directly asked. At low pressure, the value of Z for the gas is less than 1. And what is the exact value? Exact value is 1 minus A divided by VRT. Z is equal to 1 minus A divided by VRT. Z is equal to 1 minus A divided by VRT. Z value less than 1 means when the real gas is kept at low pressure, its Z value is less than 1. That means attractive forces dominate at that time. And this is the exact value. Similarly, one more direct question is asked. At high pressure, when the real gas is kept at high pressure, what about its Z value? Its Z value is greater than 1. And exactly it's equal to 1 plus A divided by VRT. And exactly it's equal to 1 plus A divided by VRT. And if the value of Z is greater than 1, that means which forces dominate? Repulsive forces dominate between the molecules. Do remove these two things as well. Okay? Do remove these two things as well. Yeah? If I give you one question like this, let me see if you can solve this or not. The question is, a non-ideal gas. Non-ideal gas means real gas. Follows the equation P multiplied by V minus B is equal to RT. Full stop. Given that dz upon dP at constant temperature is equal to X times B divided by RT. Now I'm asking you, what is the value of X? I'm asking you what is the value of X. Give it a try. Give it a try. Give it a try, everyone. And let's imagine that we have got 1 mole of the gas, okay? Let's imagine that we have got 1 mole of real gas which follows this particular equation, and this is something which is given to me. We need to get the value of X. Can we do it? What do you think? Can we do it? See guys, it's very simple basically. We have got a gas, it's following this particular equation. Okay? And over here, it's mentioned that dz upon dP, Z is compressibility factor. That means you are differentiating compressibility factor with respect to pressure. After differentiating compressibility factor with respect to pressure, you are getting X times B by RT. You have to get the value of X. How exactly are you going to solve it? It's a simple question basically. See, we have got a gas, it follows the equation P multiplied by V minus B is equal to RT. Correct? So can I write it like this? PV minus PB is equal to RT. Correct? If I divide this equation throughout divided by RT. If I divide this equation throughout divided by RT. Let's see what happens. PV by RT. PV by RT is basically Z. So Z is equal to 1 plus PB by RT. Why did I do it? Why I did this thing? Because I have to differentiate Z with respect to pressure. So I was supposed to convert this equation in the form of Z. Now since I converted this equation in the form of Z, now I'm going to differentiate this Z. I'm going to differentiate this Z with respect to pressure. So it's going to be now dz upon dP at constant temperature is equal to, differentiate this equation. This is a constant, right? Its differentiation is 0. Perfect. Differentiate this part. It is just going to be B divided by RT. Right? B divided by RT. Now do one thing. Just compare these two equations. Just compare these two equations. It is dz upon dP at constant temperature. B divided by RT, B divided by RT. Over here, X value after comparing came out to be 1. I hope this is clear to everyone. I hope this is clear to everyone. Right? Perfect? Okay? Wonderfully done. One more thing which I want to share with you. What is that? That is compressibility factor variation. Compressibility factor variation with temperature. Compressibility factor variation with temperature. How compressibility factor varies with temperature, basically. So first of all, I'm going to take two cases. When the real gas is kept at low pressure. When the real gas is kept at low pressure, let's see how its compressibility factor varies with temperature. We know when the real gas is kept at low pressure, its Z value is equal to 1 minus A divided by VRT. Correct? Let's say you have got a real gas in this particular container. This real gas is kept at low pressure. It's kept at low pressure. So its Z value will be less than 1. Okay. Now, if you increase the temperature of this real gas, if you increase its temperature, can I say A divided by VRT? If you increase the temperature, the denominator is increased. This whole term is decreased. So this term will decrease. The whole term will decrease. If the whole term is decreasing, can I say 1 minus A divided by VRT? This value. If this term is decreasing, so the difference of the two is increasing. So this whole term is increasing now. That means the value of Z is increasing. So in short, when the gas is present, when the real gas is present at low pressure, when you increase the temperature of the real gas, its Z increases. So at low pressure, Z is directly proportional to temperature. Finally, you have to remember this. At low pressure, Z is directly proportional to temperature. Similarly, at high pressure, when the real gas is kept at high pressure, Z is inversely proportional to temperature. Do remember this particular thing as well. Directly proportional to temperature, inversely proportional to temperature. Yes? Okay? Right? Perfectly done. So, one last question, with that I'll be ending. Okay? Since I was supposed to do 2 chapters, but we cannot do 2 chapters, you know it. The time has already gone. I have taken the session about 2 hours and 10 minutes. But that's okay. I'll take an extra session maybe on Sunday. Is that cool? Is that fine? Yes or no, yaar? VRMS and all that's least important in this chapter, okay? All right. Now, one last question. One last question I'm giving you. Let me see if you can solve this or not. This line represents Z is equal to 1 line. We have got few graphs here. Like this. At temperature T1. At temperature T2. At temperature T3. You need to identify which temperature is more, which temperature is less. A simple trick. Do remember this. I'm giving you one trick, okay? Just take this part. This particular part, okay? In this particular part, which is basically your high pressure region, in this particular part, that line which is closer to Z is equal to 1 line. That line which is closer to Z is equal to 1 line. That means I'm talking about this particular line. Its temperature will be always high. Without even solving anything, directly see the high pressure region, see which line is closer to Z is equal to 1, its temperature will be always high. So T1 will be always high. Okay? So guys, with this your states of matter chapter is done. There were almost some 7 important concepts. 7 important concepts in the chapter states of matter. I have discussed all these 7 important concepts from this particular chapter. Tomorrow at 9 a.m. in the morning, we have got the most predicted NEET 2023 paper, which we'll be discussing, all 4 educators together, right? Tomorrow at 9 a.m. And in the evening tomorrow, I'm going to discuss top 10 important concepts of the entire chemistry basically. I have taken those 10 concepts tomorrow. I have taken those 10 concepts of your complete chemistry tomorrow, from which every year question comes. Okay? There are some 10 concepts basically of your chemistry from which question every year comes in your NEET examination. So I'm going to discuss those 10 concepts first on priority basis tomorrow. Okay. The question which I gave you as the homework, I would want its answer in the comment section right after the session. Okay. And the PDF of the session I'll be sharing on this Telegram, even at the official Telegram as well. Okay. So people, with this I'll be taking a leave. If you have not liked the session yet, if you have not subscribed to the channel yet, this channel is completely yours, right? You need to subscribe to the channel. You need to show the lot of love and support, and thank you for the love and support which you guys have been showing till now, right? So this was our third day. In the comments, you'll be writing the answer of the homework question, and it's going to be hashtag day 3 completed, right? Hashtag day 3 completed. So tomorrow it's going to be our day 4 now. Okay. Top 10 concepts, how many marks? It's going to be top 10 concepts means top 10 questions. Okay. Perfect. I hope this much is enough. So this is something which I'll be expecting in your comments at least, right? Day 3 completed and the answer of the homework question. So let's meet up tomorrow and let's discuss the other things tomorrow. Take care. God bless you all. Love you all. Bye-bye.